space inside the solid is what volume means. In other words, the amount of cubic units that fill the solid. The amount of cubic units that fill the solid. Go ahead and draw yourself a cube, too, while you're at it, after you write that definition down. The three-dimensional space inside a solid. In other words, the amount of cubic units that fill the solid. The three-dimensional space inside a solid. I don't want to just measure surface anymore. I want to measure the inside space. So I'm figuring out how many cubes will actually fill it inside. Think of the prism. Look, I got all the prisms that you made 2 days ago. Was it yesterday? I have them right here. Do you know the surface area is 112? Think that was the surface where my hand is. But how many of these cubes would actually fill the inside? That's a volume question. That's what volume means. The amount of cubic units that fill the solid. So no longer square units. We're talking about cubes now, little cubes. And I'm going to pass these out right now. You do a little activity after the notes. These are actually exactly a cubic centimeter. Every edge is 1 centimeter exactly. So you're looking at a cubic centimeter in my hand. I got a bunch of them. I'm going to pass them out shortly. So that's what volume means. How many cubic centimeters, cubic units, cubic feet? Look at, I got different cubes up here, different size. Don't draw this. Look at a small cube. Every edge is 1 centimeter. So you got a cubic centimeter. How about a cubic foot? Or a cubic yard? So cubes can come in different sizes, right? They're all cubes, though. But depending on how we're measuring the prism, that's how many will fit inside, like ice cubes or something. In other words, look at this picture. Look at this picture. Imagine the cubes filling up the prism. Look at that. Okay, they're just filling the inside. That's what you need to be thinking about when we deal with volume. Now, get out your reference sheet. Who doesn't have a copy or lost a copy? Go ahead and get that out. I got you a either. Go ahead and bust this reference sheet out, please. You got it, Razo? You gonna bust it out? You're the man. All right, look at the volume formulas. For a rectangular prism, remember we crossed out the surface area for that one a couple of days ago? What I want you to do is also cross out the volume formula when you put your phone away at either, right? Cross out this volume formula because this one's better. The one for general prisms, go ahead and draw a box around the volume formula right here. Okay? Just like we put a box around the surface area. For our class, we're going to use a general prisms formula for volume. V, volume equals, look at capital B again. It doesn't mean base. It means, look, it tells you right here, the area of a base times the height. So we're going to use this formula for volume. And the first example I'm going to throw at you, again, you're crossing this out. You're crossing the top volume formula out and the top surface area formula out. Let's do example 1. Let's find the volume of a prism. Watch. Go ahead and draw yourself a prism. Remember, draw the top face, bottom face, connect the corners, rocking and rolling. Do that for me. Draw that one. I'll give you about a minute to draw that. We're going to find the volume of this puppy. Let's write the volume formula. I got a prism. I know it's a prism because notice this bottom face and the top face are opposite each other, and they're the same. So it's a prism, rectangular prism. Let me write down the formula. Write it down with me. V, this comes straight from our reference sheet, equals capital B times H. That's pretty easy. That looks pretty easy. It's pretty basic. But what does capital B mean again, Ataide? Area. It doesn't mean base. It means the area of the base, right? And what is the base here? What shape is the base? Anybody tell me? So the base would be the bottom face and the top face. Either one of those are the bases. There are any two faces that are opposite each other that are the same. So this could be a base, and this could be a base. Capital B means the area of one of those. You take your pick, the top or bottom one. Just find the area of it. That's what capital B means. So the top rectangle or bottom rectangle are the same. Those are the bases. Capital B says find the area of one of them. Cool. That's easy. We know how to find the area of a rectangle. You can do that in your sleep by now. Let's do it. Watch. So capital B then means the area of the rectangle, the top or bottom one. You take your pick. They're the same anyway. So the volume then, let me rewrite it. What is the area of a rectangle? How do you find the area of a rectangle? What's the formula? Thank you. Look, I'm going to put length times width. Instead of B, I'm putting length times width now. Because that's the area of a rectangle, which is the shape of the base. And then times the height. The height is actually the distance between both bases. So I can receive the distance between both bases right here is 12. That's going to be right here, the height. Let's rock and roll. I forgot to put this here. The area of the base is right here. The base is that bottom face. Here we go. Length and width of the bottom rectangle. Someone besides Ataide or Guerra, what's the width? What's the length of this bottom rectangle? The length, please. Just blurt it out. Just blurt it out. Yell it out. What's the length of this bottom rectangle? The length. Gracias. Put that right there. Width is going to be 4. Put that right there. And height, like I told you already. Nice. It's 12. You got to be kidding me. This is like easier than surface area. Just multiply 3 numbers. You got to be kidding me. But let's see. What is 5 times 4? Times 12? Someone on the calculator? Get out, hit that. What's 20 times 12? Sounds good to me. Careful now, watch this. 240 what? Chickens, horses, termites, horses, what? What kind though? Cubed, huh? We're thinking cubes now. Look at centimeters cubed. That's how many the cubes that will fill up this prism. That's what we're dealing now. Volume. Cubes, you see. So put centimeters to the 3rd power. We're rocking and rolling. I'm telling you. I've been telling you all this time. Some of you guys keep crying. Need that teddy bear. No, when you're multiplying, you can multiply any 3. So yeah, you could have done 12 times 4 and then times 5. It still would have been 240. Doesn't matter. Questions? One more and we're done. I'm gonna give you the rest of the time so you can finish 41. Yes. Let's find the volume of a cylinder. Right, Hurtado? Look at that. Example 2, last one. How do you draw a cylinder? Top face, bottom face, connect those puppies. You're rocking and rolling. Last example of the day. I'm going to draw that one. Formula for the volume of a cylinder. Blurt it out. Extra stamp. Just blurt it out. Thank you. It's the same formula. Look at your reference sheet for a cylinder. Capital B times H. You got to be kidding me. You got to be kidding me. I should be ashamed of myself for giving you something so easy. And this still means the area of the base, you guys. Come on. And this time the area of the base, what shape is the base? That's the shape of the cylinder, but what's the shape of the base? No, it's a circle. So that means instead of like we had length times width for the area of the base was length times width. Nice. The area of the base would be the area of a circle, which is pi r squared. That's the area of a circle formula. Right, Ramirez? Check this out. Volume then, watch this. Instead of capital B, what's the area of the circle's formula? I'm going to put it right here instead of capital B. Pi r squared times the height. Got to be kidding me. Got to be kidding me. It's going to be okay, Hurtado. It's going to be all right. Okay. Stick with me. I got a little snack for you after this. I got you. If you give me some effort, I got some leftover snacks. Watch this. Volume then, watch this now, is approximately, thank you. Remember pi day last week? 3.14. Radius, what's the radius here? Nice. 3 feet's the radius. So let me replace r with 3. Squared, that puppy. The height, the distance between both, 12 again. We got the same height as example 1. The rest is just, where's my calculator? Is this calculator button pushing? The rest is just calculator button pushing. This is ridiculous how easy this is. Come on, guys. Let's see. I think that's the one. But what you do first, though, Guerra? Did you multiply first, exponent? What you do? Yeah. Right, because you got to do the exponent first. Anceli. Don't piss Anceli off. Thank you. So 3 to the second power is 9. Notice that, you guys. I did the exponent first. And then the rest is just, I'm just going to, all in one soup, I'll just type that in my calculator. 3.14 times 9 times 12. I got 339.12. What kind of feet? It's volume, though. It's 3-dimensional. They're cubic feet. Cubic feet. Look at. That's how many cubes will fill that cylinder. Okay, you got to imagine this right. Cubic feet. Done.